Okay, this is question 9 from Insight 2020. So let's have a look at the lead-up questions to what is a fairly difficult final problem. So we've got this parabola here, show that the graph area enclosed by f and the x-axis is that, sure. Okay, so we're going to go and say area equals the integral between 2 and 0 for f of x dx. Now that is going to be an antiderivative. That is uh, 2 cubed is 8, negative 16 on 3 plus take away 0. Okay, so this is going to be negative 16 on 3 plus times 3 times 3 is going to be 24 on 3, which is 8 on 3 as required. Okay, so let g be the function obtained by transforming f, where this describes the transformation. So what we've got is x dash equals ax. So it's a dilation factor a from the y-axis, and this is going to be y plus 1. So y dash is equal to y plus 1. So that's a vertical translation, 1 unit to 1 unit up. So what's going to happen is that this function here will be so it's going to move up 1 unit. So like basically that point will go to there, or it should be, we should say that we'll do the dilation first. So when 0 is dilated by a factor of a from y, it will just stay here. And then it goes up 1 unit. Now when 2 is dilated by a factor of a, it becomes 2a, whatever a is. It might be, if a is 2, then it will jump to 4. If a is a half, it'll jump to 1, and it will go up 1 unit as well. So essentially the domain of g in terms of a is going to be x is an element from 0 to 2a, where that value a will determine the domain over which the function is defined. All right, for what value of a is the area enclosed by the graph of y equals g of x and the x-axis over the domain of g equal to the area enclosed by f and the x-axis? Essentially what it's basically asking is like we're going to dilate this, like let's just say that it's dilated. So let's just go a is equal to a half. I don't know whether this is the answer or not, but if a is equal to a half, what happens is that becomes there, okay, and that will go to there. So this is what my parabola will look like, okay, and this is the area underneath it, okay. So what essentially the question is saying is, when will this area here of the transform function equal the area underneath the original function, i.e. when will it be 8 on 3? Okay, so what we'll do is we'll say that 8 on 3 equals the integral between 2a and 0 enclosed by the graph of g of x. So g of x is going to be so there's f, so to do the dilation we'll do f of x on a, which is negative 2a, oopsie, 2x on a all squared, plus 4 x over a, which is negative 2x squared over a squared plus 4x over a. All right. And that's going to be a plus 1, so we have to add 1 to it as well. So let's just see if I can see it. It's the problem with doing papers on these things is you can't actually see too far above. So we've got negative 2x squared over a squared plus 4x over a plus 1 dx. All right, so what should happen is when we integrate this and slam a in, out will pop a value of a that's going to be the dilation factor that will produce the same area. Let's see how we go. So we've got 8 on 3 equals, so let's get an antiderivative of this, which will be negative 2x to the 3 over 3a squared plus 2x squared over a plus x, slot in 2a and 0. So that's going to be negative 2 multiplied by 2a all cubed, which is 8a cubed. So that's going to be negative 16a cubed over 3a squared plus 2a squared is 4a squared. That's 8a squared over a plus 2a. 0 goes in and all of those will be 0, so that's just what we've got there. All right, let's tidy up now. Got that with that, that with that. So we've got 8 on 3 equals negative 16a over 3 plus 8a plus 2a, which is just 10a. We've got 8 equals negative 16a plus, so I'm multiplying by 3, 30a. 8 equals 14a. A equals 8 on 14. A equals, what's that, 4 on 7. All right, so what we'll do now is solve f of x equals 1. What was f of x again? Negative 2x squared plus 4x. All right, so we want to go that equals 1, so 1 equals negative 2x squared plus 4x. Now this is a pretty weird thing to do as well. So whenever I have to do this, note that like it's D part 1, part 2, part 3. This will come into play somewhere else because why else would they get us to do just randomly f of x equals 1? So I'm suspicious about this and about their intentions for this. Anyway, let's go 0 equals negative 2x squared plus 4x. Take 1. 0 equals 2x squared, take 4x plus 1. So sadly, we're going to have to use the quad formula here. A equals 2, B equals negative 4, and C equals 1. Now x equals negative b, so 4 plus or minus the square root of b squared, 16, take away 4 times 2 times 1 over 2a, which is 4. X equals, so that's going to be 8, 16, take away 8. So that's 4 plus or minus 8 is 4 root 4 times root 2, 2 root 2 over 4 equals 1 plus or minus, what's that going to be? Root 2 on 2. Okay, so essentially what we've done is, that's that original graph, 0 and 2. We've basically found out when the function equals 1. So it's going to be at those points there. 1 take root 2 on 2 and 1 plus root 2 on 2. So that's 1 plus root 2 on 2, 1 take root 2 on 2. And remember that that might come into play because remember the other function there goes up 1 unit, okay, and it will be dilated as well. So that's what's going to happen to that one there. All right, so, okay, when a equals 3, f of x equals g of x has a unique solution. All right, so 3. So if we do f of x and g of x, all right, yeah. So f of x is that function 2x squared plus 4x equals, so g of x is going to be f of x on 3, that's the dilation factor 3, plus 1, which is going to be negative 2x on 3 squared plus 4x on 3 plus 1 equals negative 2x squared on 9 plus 4x on 3 plus 1, negative 2x squared plus 4x. All right, let's chop some of these denominators out and probably try discriminant, I think. But let's just, yeah, let's get these denominators out and swing everything onto the right or left-hand side. I'm going to multiply by 9 first of all, so that's negative 18x squared plus 36x equals negative 2x squared. 9 fours are 36. 36 divided by 3 is 12 plus 9. Okay, now let's chuck them onto the right hand side. So we've got 16x squared, take 24x plus 9. Now this should be a perfect square. So show that it has a unique solution. Yeah, let's just go factorize on that. F 4x, 4x, 3, 3. That should be 12 and 12. Yes, good. Equals 4x take 3 all squared equals 0 equals 0. Therefore, x is equal to 3 on 4, which means one solution as required. Okay, so here's the hard one. Let D be the intersection of the domains of F and G. So D is the intersection of the domains of the two. What values of A is G of X greater than F of X for X is an element of D? Okay, so remember, yeah, we've got that function there. Then we've got this other one that goes up. Let's just say that's 1 unit there. So it goes up 1 unit and dilated by a factor of something from, I think this was 2, if I'm not mistaken. Yeah, 2, right? So it's going to go up to 1 to 3. So there's 1, there's 2. So it's going to be like, so if I do a really small value of A, what's going to happen is we get something like this. So A, what it's going to do is it's going to keep it getting bigger and bigger and bigger until what's going to happen is at some point that value there is going to send this portion of it below this original function here, f of x, And what that means is that g of x isn't greater than f of x. Right, so what we're going to do is we're going to dilate it as far as we can until we basically hit this, this point here where it intersects with the graph. Now, the point of intersection of the graph is actually this one here. All right, so what we actually want to do is we know that our value of this transformed function, so it's going to be x is an element from 0 to 2a, right? So that's what we know. What we want to know is that value there, 2a, needs to equal this particular value here, 1 take root 2 on 2. So that's basically saying what value of a will dilate this until it hits this point here. So what we'll do is we'll just solve that. So 2a take 1. Actually, what am I doing? I'm solving for a. So I need to divide by a. A is equal to half. Take away root 2 on 4. Let's just simplify that. I'll get a common denominator anyway. So I've got 2 take away root 2 over 4. Okay, so that's basically going to get us to this point here. So the value a is going to get us to intersect with the parabola there. What we want to do then is it's going to be below, 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 below until it gets dilated far enough that it actually intersects there, at that one there. So that's going to be the positive one on this. So it's going to be 2a multiplied by, to get the positive root 2 on 2. So a is equal to a half plus root 2 on 4. And obviously that's going to be a equals 2 plus root 2 all over 4. All right, so what do we know so far? So we know that x is going to be an element, okay, and I can start dilating by values, so 0 up to 2 take root 2 on 4, but not including it because it's got to be greater than it. Right, so what that will do is it's got to be a value larger than 0, otherwise if a is equal to 0, it basically chops out the function. The function doesn't exist, I think. Yeah, it doesn't. So values larger than 0 will dilate it to this point here. Then what we're going to do is continue dilating after this point here. So this point here makes the first point on this side of the function for it to be true. And what we want to do is keep dilating, keep dilating, keep dilating. How far do we go? Well, what's going to happen eventually is this part here is going to touch this point here. So what we're going to get is basically like a touch or a tangent or a unique solution. And that's actually what they got you to do this for. Okay, so this one here, show that when a is equal to 3, f of x equals g of x has a unique solution, and that's going to be at this point here at x is equal to 3/4. So what happens is you'll dilate enough that this point here will end up touching the graph here below it, and after that it'll start to intersect it. All right, and I'll try to demonstrate this with GeoGebra in a sec. So what we're going to do is say that, okay, so these are the first values for which it's true, and then we'll pick it up again at 2 plus root 2 on 4, and we'll keep going all the way to 3. Are we going to include it? No, because that's when they're the same, so it's going to be till 3. So it's probably the best we kind of look at that and see see how it works. Okay, so our first function was function negative 2x squared take, oh god, what was it? Negative 2x squared plus 4x. between 0 and 2. Yeah, that looks good. Okay, and our other function was, so I'm going to do f of x over a plus 1. All right, so there's our other function. So when a is equal to 1, basically it's just vertically translated. And basically, yeah, so you can see kind of how it works here. Let's try to see if we can skip through the values. Slider, what are we going up by? Increment, let's go an increment of 0.1, so this happens slowly. Okay, so what you can see here with an a value of 0.1, we get g of x is always above f of x over its domain, right? Now, between 0.1 and 0.2, it's going to go below. So that value there is the first value that we found down here. That's 2 take root 2 over 4 sits right there. So that's going to be the dilation factor to get it to hit it. Right, so now notice that we've got, it isn't above it for all values. So that basically is not allowed. And if we keep dilating, right, so if I keep going across, eventually it'll go to the other side, which is this value here. And it will keep being more than it until what happens is if I keep dilating all the way over to when this is equal to 3, this graph here will end up touching it. Let's just see what happens. Here we go. No, that didn't work. A is equal to 1.5. All right, so let's keep going. Yeah, see, you can see it's getting closer and closer, and at 3, it touches. Now, why not more than 3? Well, what will happen is it'll go below here. So let's see. You can see here, more than 3, we go below, or this one goes above. So 3 is the threshold there. So you can kind of see how they've tried to tell you that that these answers matter for this one here by making it all part of the same question. So D part 1, D part 2, D part 3. Pretty tough question to do without parameters and calculators, but it's actually a fairly easy function to work with. Like if this was another type of function, it might be a bit harder, but anyway, see how you go with that and understanding that, but that's the best kind of explanation I can give for it.